All right, question 2 says approximately 10% of all people are left-handed. Consider a grouping of 15 people. State the random variable. Well, that's weird because it doesn't really say what we're counting. Are we counting the number of left-handed people or are we counting the number of right-handed people? So let's assume that they mean X is the number of left-handed people. So for part A, we're going to say X equals the number of left-handed people. For part B, it says, argue that this is a binomial experiment. Well, in order for something to be binomial, you have to have independent events. So we'll assume that X is independent. That just means that the probability of one person left-handed doesn't change the probability of the next person left-handed. So that seems reasonable. We're interested in the number of left-handed people out of, 15 people? So we have to be counting up the number of successes out of a fixed number of trials. So N is fixed. The probability is fixed, so P equals 0.10 for person to person. So we have independent events, fixed number of trials, fixed probability, and we're interested in the number of successes out of 15 tries. So therefore it fits all four classifications. Part C, probability that none are left-handed. So we can do that in the calculator, right? So we're just going to type this all in as a binomial. I don't have to, right? I could go, if none are left-handed, then all of them are right-handed. So that's going to be 0.9 raised to the 15th power. So we'll go 0.9 raised to the 15th, and I get 0.2058. But remember, I could have gone to distribution and done binomial PDF and typed in there's 15 trials, the probability of success is 0.1, the X value is 0. I'm just going to go ahead because I think I'm going to be using these later on. So I'm just going to go ahead and paste this in list 1. And then we'll go stat edit, and then right there, that's the probability that none of them, 0.2058, same thing. D. 7 are left-handed. Well, there's 0, 1, so there's 0, 1, 2, 3, 4, 5, 6, 7. So that's 2.77 times 10 to the negative 4th. So the probability that X equals 7, so that's going to be 0.000277. Now remember, the formula for that would have been the combination of 15 things taken 7 at a time times 0.1 raised to the 7th times 0.9 raised to the, 8th? So there's 7 left-handed and there's 8 right-handed. So, and that'll turn out to be this number as well. E, at least 2 are left-handed. So E, remember that language, at least, means the probability that X is greater than or equal to 2, not less than or equal to 2. So the minimum amount that's acceptable is 2, so 2 or more. So I'm going to do that again in the binomial calculation. This will be a CDF command. So I'm going to quit out of here. So I'm going to go distribution, binomial CDF, and there's 15 trials. The probability of success is 0.1. And I'm going to enter the X value of 1, because at least 2 means 2 or more. So I'm going to add up from 0 to 1, and I get 0.549, so 1 minus that is 0.45. So the probability that X is greater than or equal to 2 is approximately 45%. At most 3, so that's F, so that's the probability that X is less than or equal to 3, right? The most I can have is 3. So this one, the CDF command, works nicely. I don't have to do any subtraction. So 15 trials, 10% chance of success, and up to 3, and that turns out to be 0.944. And then H, 7 of the last 15 presidents were left-handed. Is this unusual? What does that tell you? All right, so for H, if I asked for, well, what's the probability that, let's see, 7 of the last 15. So the probability, what's the likelihood that we had more than 7? So the probability that X is greater than 7. We'll go greater than or equal to 7. So if I go distribution, binomial P CDF, and we go 15 trials, 0.1, up to 6, so we're 99% likely, 0.999% likely to have up to 6 of the last 15 presidents to be left-handed. So the probability that there were more than 6, which would be 7 or more, is only 0.001. So what does that tell us? Well, maybe there's something about left-handed people that makes them more appealing to the population at large. Maybe left-handed people tend to go into politics more often than right-handed people. There's all sorts of interesting things that we might conclude about that, but it's all going to be supposition. What we know for sure is it's very unusual for us to have 7 or more left-handed people out of 15. So perhaps left-handedness and going into politics are somehow associated with each other.